Hello, this is Mr. Collier, and today we're going to be looking at how to find the slope or the gradient of a line. Okay, so you can always look at a line to see if it's a positive or negative slope right away. You can look at these lines, and if it's going uphill from left to right, that's a positive gradient, and if it's going downhill from left to right, it's a negative gradient. Okay, so to calculate the gradient on a graph, you get the vertical change divided by the horizontal change, which we call rise over run. Okay, and here's the formula you can use if you have the coordinates. You can subtract the y values divided by the difference of the x values gives you the rise over run. Okay, so we're going to look at a couple of examples. Here, we determine the gradient of this interval below. So we're going to look at the rise and the run. Well, the rise is, we can go from any point to another point, but let's go from this point to this point right here. That's up 4, and it is to the right 1, 2, 3, 4, 5, 6, 7. So in here the slope is going to be 4 out of 7, the rise over the run. Okay, and I'm going to draw a line segment that has a gradient of negative 4/3. So that means that you could say that that's negative 4 out of 3. So the rise is negative 4 and the run is 3. Or you could even say it as 4 over negative 3. So the rise is 4, the run is negative 3. So, and we can draw a line anywhere we want. We don't have any other points, we just have the slope. So I'm just going to start with like this point. And I'm going to do a rise of negative 4, that means down 4, 1, 2, 3, 4, and a run of positive 3. And you can draw a line there like that. Okay, we're going to find the gradient of line passing through these 2 points, and we can use the formula slope equals y2 minus y1 out of x2 minus x1. And just make sure we don't, we can pick either point for y1, x1, but just make sure you're consistent with your coordinates. So we have y2 minus y1 is 11 minus 5. On the bottom we have to do negative 5 minus negative 2. So be careful, that's a negative 5 minus negative 2, which equals 6 out of negative 5 plus 2, which equals 6 out of negative 3, which equals negative 2. Okay, let's look at another one here. We're calculating the slope of these 2 lines. So the key is you want to find easy points to work with. Now this point looks like a fraction, so I'm going to pick this point and this point on this line to find the slope. Okay, looking at the line, looks like it's downhill, so it should be a negative slope. So keep that in mind. The rise is positive 2. The run is going to the left, so it's negative. So your rise over run is 2 out of negative 1. So for that line, your slope equals 2 out of negative 1, which equals negative 2. Now for the next line, we need to find some points that are integers to make it easier. Here's a point. And here's another point, I believe. Is that a point? Yes, I think so. Careful. Okay. So the rise is 1 and the run is 3. So the slope for the second line is 1 out of 3, or 1/3. Okay, so now we're given the slope. We have to sketch some lines with these slopes. Sketch a line with gradient or slope 2/3. So I'm going to start with 1 again to make my life easier here. And a slope of 2/3 means the rise is 2, the run is 3. So we have this point, and I can draw more points too. Just go up 2, right 3, up 2, right 3, and I'm going to draw a nice straight line here now, hopefully. There you go. Alright, and then next we're drawing a line with slope of -2. So what's the rise and the run here? Well, you can write it as a fraction if that helps. So the rise is -2, the run is 1. I'm going to start with maybe this point here. So I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Then I can connect the dots. Okay, so that's my second line with a slope of -2, and this line here has a slope of 2/3. Okay, in the next example, what is the slope of a line passing through these 2 points? We did one like that before. We can use the formula slope equals y2 minus y1 out of x2 minus x1. So we can do -2 minus 3, and we went this way before, so we're going to go this way with 6 minus 1. We get -5 out of 5, which equals -1. Now a line with gradient 2 passes through these 2 points. Find A. Well, we can use a slope formula because they give us the slope. So again, m equals y2 minus y1 out of x2 minus x1. And we're going to substitute in m is 2. We don't know y2, so that's going to be our variable. We'll call that A, as it's called right there. So A minus 12 out of -1 minus 2. Then we can simplify a little bit. We'll have A minus 12 out of -3. Okay, and then we need to get rid of that -3 down there, so we can multiply both sides of the equation by -3. And then we will get -6 equals A minus 12, and then we simply add 12 to both sides to get the value of A. So we have 6 equals A is our answer. Okay, in the last example, this is a modeling example. So this line here models wages paid to sales assistants. Okay, what does the intercept on the vertical axis mean? So if we look at the intercept on the vertical axis, we have $80. And the thing is, this is after 0 hours worked, you get $80. So I think some people call this the shift pay. You get an $80 amount no matter how many hours you work. Okay, so you get so you can say that you get, or the assistants get paid, they get paid $80 per shift or something. They always get $80 depending, and that doesn't depend on the number of hours they work. Okay, find the gradient of the line. What does that mean? Well, the gradient is going to be rise over run. We can pick a couple points here, but we can see maybe from this point to this point that we go up, the y value increases by 60, and the x value increases by 4. So your slope is rise out of run, which is 60 out of 4, which equals $15. That means workers get $15 per hour. Okay, next. Determine the wages for working 6 hours and 18 hours. Okay, so 6 hours is in here. Actually, let's make a formula, make an equation, then we can calculate that pretty easily. So we're going to call this the x-axis and the y-axis. We could use h and w if we want to, but I'm going to call it y and x. And we know that the slope is 15, and we know that the intercept is 80, so there's our equation. So for part I, I'm going to work out y equals 15 times 60 plus 80. So 15 times 60 plus 80 is going to give me $980. Okay, so y equals, oops, pardon me, that was 6 hours, not 60 hours. So if I use 15 times 6 plus 80, I actually get, let's see, 15 times 6 plus 80 is actually $170. $170. And second part, we'll have y equals 15 times 18 plus 80, which equals 15 times 18 plus 80 is $350. Okay, so part D, if no payment was made for not working, but the same payment was made for 8 hours of work, what would be the new rate of pay? Okay, so what part D is saying is, if we don't have that initial $80 per shift, and you want to make the rate of pay, the amount of pay, the same for 8 hours of work, what would the new rate be? So it wouldn't be $15 per hour, because that wouldn't get you up to, actually let's work out the amount you get for 8 hours of work first. So for 8 hours of work, you get 15 times 8 plus 80, which equals $200. So right now with this model here, if you work 8 hours, you get $200. We want the same thing to happen if you work for 8 hours but get 0 pay at the beginning. So your new function is going to look like, well, let's do it this way. We'll have y equals mx plus b. We'll start off with the general equation. But you're not going to get anything at the beginning. You're not going to get any money at all. So it's just going to be y equals mx. Y equals the slope times x. And the slope is the new rate of pay. We don't know that, but we know after 8 hours we want to be making $200. So we're going to have m times 8 equals 200. And then we just divide by 8. And we'll get m equals $25, and that's a rate, so $25 per hour would get you $200 after 8 hours. So that would be the new rate of pay you need in order to replace the shift pay system.